Okay, I love these problems. Sketch a graph of the function f of x that satisfies all of the following limits. So the limit as x approaches 3 of f of x exists, but f of 3 does not exist. Well, for that to happen, we either need to have a hole at 3, maybe draw it like that or something. Maybe we have a hole at 3, or maybe we have a vertical asymptote at 3 where the tails go together like that. I'm going to do a hole because I think that's going to be the easiest way to show it. Let's look at the next thing. Limit as x approaches 4 f of x is 0. Well, the easiest way to do that is just to 1, 2, 3, 4, make an x-intercept at 4, right? Because the limit's telling us the y value is 0 as we approach the x value 4. So just make an x-intercept there. Limit as x approaches -1 from the right. Well, -1, there we are, from the right, is infinity. So if the limit is infinity, we're talking about a vertical asymptote there. And it's positive infinity, so my graph has to be coming like that. Okay? And finally, the limit as x approach is infinity, so now we're talking about a horizontal asymptote, is 5. So let's go 1, 2, 3, 4, 5. I need to have a horizontal asymptote there. Okay. Well, what else did we need? We said we needed a hole at 3. So right here at 3, we need a hole. Okay. So this graph has to come down, hit that hole, right? I have to hit that 0, but I need to approach that horizontal asymptote. So maybe I'll make it bounce and go up like that. That's one option. Well, have we satisfied everything? Let's see. Does f of 3 exist? No, because there's a hole there. Does the limit exist? Yes, because there's a hole there. As x approaches 4, is the limit 0? Yes, because we have an x-intercept. It bounces. That's totally fine. And as we approach -1 from the right, are we at infinity? Yes, we are. So to finish this off, maybe our branch just goes like that. And now the second part says write this equation. So let's write the equation. Well, I have an x intercept at the x value of 4, so that means I have an x minus 4 in the numerator. It bounces, so I know it's an even power, so let's give it a squared. I also know I have a hole at x minus 3, so I have to have an x minus 3 in the top and in the bottom. What about the vertical asymptote? Well, the vertical asymptote is at -1, so I need an x plus 1 there, and the tails are going together, so I need a squared. This thing currently has a horizontal asymptote at 1, because the degree in the top is the same as the degree in the bottom, and I want it at 5, so I need to put a 5 in front, and voila, this is my function f of x. Do you have to do it in the same way? Absolutely not. Infinitely many answers. Get creative. This was my answer.